Our journey into the realm of dinosaur myths begins with a question of scale. It's easy to imagine dinosaurs as towering behemoths, shaking the ground with their every step. And while it's true that many dinosaurs reached staggering sizes, the fossil record tells a more nuanced story. Picture the fearsome Tyrannosaurus rex, its massive jaws agape in a thunderous roar. This apex predator, stretching over 40 feet long, embodies the image of dinosaur gigantism. But now, imagine a creature no larger than a chicken, darting through the undergrowth. This, my friends, was Compsognathus, a diminutive dinosaur that challenges our assumptions about dinosaur size. The truth is, dinosaurs came in a spectacular range of sizes, from the thunder lizards to creatures no bigger than a house cat. To understand this diversity, we turn to the fossil record, a treasure trove of information about these ancient creatures. Paleontologists, those intrepid detectives of the prehistoric world, have unearthed the remains of dinosaurs both large and small, painting a vivid picture of the ecosystems they inhabited. Let's delve deeper into this world, guided by the expertise of Dr. Paleontologist's name, a leading expert in dinosaur paleontology.
Well, just like in animals today, size played a crucial role in a dinosaur's life. Larger dinosaurs, like the sauropods with their long necks and massive bodies, were able to reach high into the trees for food, outcompeting smaller herbivores. Their size also provided a significant defense against predators. On the other hand, smaller dinosaurs, like the agile velociraptors, relied on speed and agility to hunt prey or escape from larger predators.
This fascinating interplay between size, diet, and environment resulted in a breathtaking diversity of dinosaur species, each uniquely adapted to its ecological niche. Our exploration of dinosaur myths takes us now to the very essence of their being, their metabolism. For years, the prevailing image of dinosaurs portrayed them as lumbering, cold-blooded reptiles, their movements dictated by the whims of the sun. But just as our understanding of dinosaur size has evolved, so too has our understanding of their metabolic processes. Recent scientific discoveries have challenged the notion of dinosaurs as sluggish ectotherms, presenting compelling evidence that many dinosaurs possessed warm-blooded metabolisms akin to modern birds and mammals. To unravel this mystery, we must journey deep inside the dinosaur, to the very cells that powered their existence. Imagine, if you will, the thundering heart of a triceratops, pumping blood throughout its massive frame, fueling its muscles, and maintaining a constant internal temperature. This, my friends, is the hallmark of a warm-blooded creature, an animal capable of generating its own body heat and regulating its temperature regardless of the external environment. But what evidence supports this revolutionary idea? Scientists have uncovered a number of clues, hidden within the very bones of dinosaurs. One such clue lies in the structure of dinosaur bones themselves. Unlike the dense, slow-growing bones of reptiles, many dinosaur bones exhibit a porous, fast-growing structure, characteristic of warm-blooded animals. This suggests that dinosaurs experienced rapid growth rates, fueled by a high metabolism. Furthermore, the discovery of feathered dinosaurs in recent decades has provided compelling evidence for warm-bloodedness in dinosaurs. Feathers, those marvels of evolutionary engineering, serve as insulation, helping animals conserve body heat. The presence of feathers on many dinosaur species, including close relatives of Velociraptor and Tyrannosaurus rex, strongly suggests that these animals maintained a constant internal temperature, just like modern birds. Expert opinions further solidify this emerging view of dinosaurs as dynamic, warm-blooded creatures.
The evidence for warm-bloodedness in dinosaurs is mounting rapidly.
So, while the image of dinosaurs as sluggish, cold-blooded reptiles might linger in popular imagination, the scientific community is rapidly embracing a new understanding of these fascinating creatures. Our next myth-busting adventure takes us to the very heart of human fascination with dinosaurs, the tantalizing yet entirely false notion that humans and dinosaurs once walked the earth together. It's an image often portrayed in popular culture, humans fleeing in terror from charging triceratops, or brave warriors facing down a mighty Tyrannosaurus rex. But as captivating as this image might be, it's a product of fantasy, not reality. The truth, as revealed by the fossil record, paints a very different picture. S3, as Dr. Paleontologist's name. Dinosaurs, those magnificent rulers of the Mesozoic era, met their demise some 66 million years ago, wiped out by a cataclysmic event, most likely an asteroid impact. Humans, on the other hand, emerged on the evolutionary stage a mere few million years ago, a blink of an eye in geological time. To put this into perspective, imagine the entire history of the Earth compressed into a single year. Dinosaurs would have ruled for most of the year, from the early spring to the late fall. Humans, on the other hand, wouldn't appear until the last few minutes of December 31st. The fossil record unequivocally confirms this separation of eras.
The fossil record is incredibly clear on this point. There is absolutely no evidence to support the idea that humans and dinosaurs ever shared the planet.
Our exploration of dinosaur myths takes us now to a truth so profound, so awe-inspiring, that it rewrites our very understanding of these prehistoric creatures. For far from disappearing entirely from the face of the Earth, dinosaurs live on today, not in some hidden corner of the world, but soaring through our skies, chirping in our gardens, and even gracing our dinner tables. S4, as Dr. Paleontologist's name. That's right, my friends. Birds are not merely descendants of dinosaurs, they are dinosaurs, the living legacy of a lineage that stretches back millions of years. This remarkable evolutionary journey began millions of years ago, with small, feathered dinosaurs, creatures like Archaeopteryx, showcasing the first hints of avian characteristics. These feathered pioneers possessed a unique blend of reptilian and avian traits, a testament to the power of natural selection to shape life in extraordinary ways. Over eons, these avian dinosaurs continued to evolve, their feathers becoming more specialized for flight, their bones becoming lighter and hollow, their metabolisms adapting to the demands of soaring through the air. S4, as Dr. Paleontologist's name. The result of this extraordinary evolutionary journey is the breathtaking diversity of birds we see today, from the tiny hummingbird to the majestic eagle, each a testament to the enduring legacy of the dinosaurs. The evidence for this dinosaurian ancestry is overwhelming, etched into the very bones and DNA of birds. Paleontologists have uncovered a treasure trove of transitional fossils, creatures caught in the act of evolving from dinosaurs to birds, their skeletons displaying a mosaic of reptilian and avian features. Genetic studies further confirm this lineage, revealing remarkable similarities between the DNA of birds and their dinosaur ancestors. Our final myth-busting adventure takes us to the very foundation of dinosaur classification, challenging a misconception that often lumps these magnificent creatures with their reptilian distant cousins, the lizards. While it's true that dinosaurs and lizards share some superficial similarities, both possessing scales and laying eggs, a deeper dive into their anatomy reveals a world of difference, a testament to the unique evolutionary paths these two groups have taken. S5, as Dr. Paleontologist's name. One of the most striking differences lies in their posture. Lizards, like most reptiles, sprawl, their limbs extending outwards from the sides of their bodies. This sprawling posture results in a side-to-side gait, limiting their speed and agility. Dinosaurs, on the other hand, possessed an upright stance, their limbs positioned directly beneath their bodies, much like mammals and birds. This revolutionary posture provided dinosaurs with superior speed, agility, and endurance, allowing them to conquer a wide range of ecological niches. Another key difference lies in their skulls. Lizard skulls are relatively simple and inflexible, limiting their bite force and feeding strategies. Dinosaur skulls, on the other hand, exhibit a remarkable degree of complexity and variation, with different species evolving specialized skulls for different diets, from the bone-crushing jaws of Tyrannosaurus rex to the beak-like mouths of herbivorous dinosaurs. S5, as Dr. Paleontologist's name. Furthermore, dinosaurs possessed a feature entirely absent in lizards, a unique respiratory system. While lizards rely on simple lungs for respiration, dinosaurs evolved a complex system of air sacs connected to their lungs. This avian-like respiratory system, still present in birds today, allowed dinosaurs to extract oxygen from the air far more efficiently, providing them with the stamina required for an active lifestyle. The anatomical differences between dinosaurs and lizards are profound, reflecting their distinct evolutionary histories. And so, we conclude our exploration of dinosaur myths, having separated fact from fiction and uncovered the truth about these incredible creatures. From their diverse sizes and warm-blooded metabolisms to their avian descendants and unique anatomical features, dinosaurs continue to captivate our imaginations and inspire awe. Don't forget to like, share, and subscribe for more fascinating dinosaur content. Until next time, keep exploring the wonders of the prehistoric world.